Okay, welcome to the first session on forensics investigations. This is an introduction to the unit, and I'm going to recap some of the stuff that I said on the Moodle introduction and also outline what we're going to be doing for this unit for most of the teaching block. So you have available to you the Digital Forensics Lab, which is Buckingham Building 011. That's available every week. That's every Tuesday from 9 AM to 12 PM. I will be emailing you every Monday on a weekly basis to tell you what's happening during that week. There will be one primary image that you'll use for most of the semester, most of the teaching block. That's available on the server in Digital Forensics Lab. It's also available to download from Google Drive, and there's a link on Moodle to get access to that. And what you need to do this week is essentially get it ready for examination. There's an indicative schedule here. So we're on the first session, which is an introduction. That is online only. We're then going to be moving into looking at specifically things associated with Windows. So I'm going to be running the session on Windows Registry, on internet browsers. Then we're going to be looking at investigation of email, so email forensics. There'll be something online for you to look at, which is based around file sharing. Then we'll have a look at some activities associated with forensic analysis of network traffic. And then we'll look at some images and some techniques that are used in order to identify images that are being shared. So those are the sessions that I will be covering, that Nick Savage will be covering. And then we have some sessions on Linux intrusion forensics, forensic of a Linux box that's been hacked into. We're going to be covering some live forensics, that's volatile memory forensics, and then some really cool stuff on mobile forensics. So the first part of the unit, there's a fair amount of Windows stuff there. And the second part that Adam's going to be dealing with covers some interesting stuff. Adam will also be covering some aspects of the assignment for you. So how are you going to be assessed on this unit? Now, there's going to be a digital investigation that's worth 70% of the unit. That is going to be set on the 14th of March. That is due in on Friday, the 28th of April. There are some other units that you'll have assessments for, so please ensure that you plan ahead for this. I strongly advise you have a look at the challenge for this week, and the challenge is to identify resources for writing technical reports, for presenting information in a forensic report, and that will help you in compiling your report that you have to submit on the 28th of April. There's also an in-class test, which is worth 30%. That is scheduled for the second week of the CAP period. So that is the second week back after the Easter break. You have an in-class test to do with that. So, as I said, we're going to be looking at an operating system, and particularly we're going to be looking at Windows. And I'm just going to give a brief background to what an operating system does. So, an operating system is going to manage all of the interrupts that might occur through any of the peripheral devices that you have connected to your computer system. Manage time, I tend to call that being a soft interrupt. It will manage the memory associated with the computer system. It will manage any of the processes that are started, and it will manage all of the devices that are connected to the computer. It also performs some form of higher level management, such as a file system, such as managing users, user access rights, authentication, managing the user interfaces that are being drawn onto the screen, so things are being written to the display driver, managing any applications and the needs of the applications that are running on the operating system. The operating system will tend to try to manage processes so that there's some form of balancing between all the processes that want to get access to central processing unit, balancing the fairness to access to things like the memory as well. Now, in particular, we're going to focus on Windows, and I just have a few slides here to outline some history of Windows. So it is a mainstream operating system that is used by many laptops and PCs at the moment. For some reason, Windows hasn't been that dominant on the mobile market. But pre-Windows, before Windows was sort of developed, Microsoft owned an operating system called the Disk operating system, otherwise known as DOS. And then it released Windows 1.0 in November 1985. And the idea was to compete with Apple Macintosh. Microsoft actually developed the Apple Macintosh, or helped develop the Apple Macintosh operating system in about January 1984 or so. And so, really it was to compete between Windows and Apple Macintosh. Unix machines at the time were predominantly sort of servers, sort of really quite high-level processing. And well, Apple Macintosh were looking to put machines onto the desktops of every home. In fact, I think Windows or Microsoft were looking to do that as well. Windows 2 released in December 1987. It introduced the concept of having tiled windows, so each process had access to a window that the user was able to interact with. And apparently, Apple thought that was a patent infringement and tried to sue Microsoft. In fact, it sued Microsoft for quite a few patent infringements and didn't win on any of them, so that's rather unfortunate. And then we move on to Windows 3, 3.1, and this is where Microsoft introduced virtual memory. And if you start to look back historically at the way that Windows has been developed, there's a lot of core architecture that hasn't changed very much over the years. And memory management processes being one of them for a large number of the Windows systems. It also allowed networking support via WinSock, so you're able to send stuff over TCP IP using some of the APIs that Windows had built into it. We then move on to Windows 95, Windows 98. You're allowed to have long file names. There was support for 32-bit architectures. Windows 2000 as well. Moving on to Windows XP. Windows XP has been dominant for a large number of years now and seems to be embedded in lots of different stuff. And that combined what Windows had as a server operating system, known as Windows NT, with its other sort of home-based operating systems at the time would be Windows 2000. And then Microsoft wanted to go through a bit of a redesign. There is a famous memo from Bill Gates, I can't remember when, 2001, 2002 I think, talking about the fact that security needs to be embedded into the development that Microsoft does. Windows Vista had a significant amount of security improvements made to it. It had a fair amount of stuff that had been redesigned and rebuilt. Didn't seem to be particularly popular, but then Windows 7, okay, we now have a new design with a new shell, a new taskbar, where some performance improvements, security improvements built in, so things like address layout randomization. These things are all integrated into Microsoft products, Microsoft operating systems. And then we move on to now, where we have Windows 8, Windows 10, really significant user interface redesign. They developed, or they used, some faster boot technology. There were security features sort of integrated. I mean, they improved the address space layout randomization. It also had integration with some of the Microsoft cloud-based services, so SkyDrive. It was produced for tablets and any other touch-enabled interfaces. Now, Windows has, and this is just ripped off of Wikipedia, Windows has a fairly dominant market share, as you can see. If I move the mouse over here, we're talking desktop and laptop stuff of being 90% of the market share, and Linux being fairly small. We then move on to, of course, Apple's based on BSD, so that's a Unix-based operating system. Smartphone tablets, majority being Android, very few being Windows devices on the smartphone. And then server tends to be sort of Linux, Unix-based. Windows has about a third of the number there, and then supercomputer, most supercomputers around the world are Linux-based. Mainframes tend to be Unix-based, and then gaming consoles, depending on whether you're a PlayStation or an Xbox fan. And then a little bit on embedded systems, some of those being proprietary operating systems. See the large number of other over here, but a large number of Linux-based, sort of Android-based systems running embedded. But predominantly your desktop, laptop systems are going to be running Windows, hence the reason why we're focusing on it here. Now, I want to run through what happens when you typically boot up a system. And so we'll have something that's stored on the motherboard called BIOS, and that will enable your computer system to say, hey, what am I going to be loading? What do I do next? So when power is turned on to a PC or a laptop, you'll be loading up a very small operating system that will enable you or allow you to load the main operating system for the system. And so BIOS is going to sort of initialize hardware. You may have seen sort of memory checks taking place, I don't know. And it will load the master boot record from whatever device is being configured as a boot device in your BIOS configuration. And the boot sector is then loaded into particular memory address in RAM, and BIOS passes control to your boot sector, passes control to your whatever your boot manager is. And that will look at the partition table, so it will find the boot partition, it will load whatever is in the boot partition and execute that. And it may be that if there are multiple operating systems found, so if you have multiple operating systems found, you'll be presented with a menu that will enable you to load one of those operating systems. For Windows, it will search for a particular file called hyberfil.sys, and that is a file that is storing all of the current Windows configuration if you put the Windows machine into hibernate mode. And if it does find that file, it's going to load that. If it doesn't find that file, it's going to start Windows. If you're on a Windows machine, if you started the Windows partition, and it'll pass control to a particular executable called the kernel executable, and it will also use the DLL there, which is a dynamic linked library of the hardware abstraction layer, so the how.dll file. We then move on to using something called the current control set. And the current control set is a registry setting that will define a variety of different boot time configuration options. And you have a few current control sets that are available to you in the registry. Things like, this is how the device was configured last time it booted cleanly, this is what the current configuration is like, and this is what the last boot file, the boot time was like. I'd advise having a look at the current control set to sort of see what that is and how it's used by Windows. The bootloader passes control to the kernel. The kernel initializes a variety of drivers, and then we start up the session manager subsystem, the SMSS executable that does a whole variety of things. That manages Windows displaying, using applications, and interacting with the user. So it mounts up whatever disks it has available to it, checks for consistency, creates any environment variables, starts the Windows subsystem for graphics, starts client-server runtime subsystems, creates virtual memory systems, and launches whatever authentication is being used in order to authenticate against the, in order for the user to authenticate. Now, a Windows system has a fairly standard file system layout, and indicated here there is a drive that's given the letter C. We'll refer to that as being the C drive, and if your background is Linux or Unix, we'll call that root, a slash. And then we have a folder, a directory above that called Documents and Settings. We have another directory called System Volume Information, a directory called Users that stores all of the user files, and a directory is called Windows. And in these directories, we'll find a lot of files that will be of use for forensic analysis. There are a variety of programs that will be stored in the root, so the C/program files or the C/program files x86. If you happen to have a 32-bit executable that you want to run on a 64-bit version of Windows, so Windows splits up 64-bit and 32-bit executable files between those two directories. And those two directories are going to contain all of your executable files, your binary files, that's exe files, dynamic link data, dynamic link libraries, some data. There will be some global DLLs, dynamic link libraries. So if you're familiar with Unix and Linux, these are shared objects. Sorry, actually, I think that's only Linux that are shared objects. Those will be installed on C Windows System 32, so that whatever program has been developed is able to get access to some fairly standard programming interfaces. And then temporary files will typically go into some user directory that's indicated here, so appdata/local/temp, or /windows/temp, or /temp. There are some fairly standard file types that are being used, and these are denoted by a postfix to the file name. So that dot being after the end of the file name, and then .exe tends to be an executable file. It's a binary file. It's something you can execute within the Windows operating system. There's a .dll, it's dynamic link library. That is a file that executable files may need in order to get some functionality. There's a system file, configuration file, so .sys, a system file. Ini is a configuration file. You might find something called a batch file, .bat. There are generic data files that have .dat after them, and .chm is a Microsoft help file. Now, next week, you're going to be looking at something called the registry. It's a central database which is used by Windows in order to manage how the installed programs are going to run. And the registry does store a lot of configuration options, but it also stores a lot of forensically valuable information. You'll see once we start to look at the registry that it will store things like IP addresses that have been accessed, URLs that have been accessed, when things were last used, what files were last used by particular applications. So it's quite a useful resource in order to look at. It's also nice of Windows to present one central resource to get all of this forensically valuable information. I will start having a look at that next week. Now, I'll just finish off here because we'll be doing a little bit about live forensics, volatile forensics now. Windows, in a very similar way to Linux, it breaks memory down into an area of memory that is being used by the kernel, an area of memory that is being used by programs, and exactly the same way memory is paged. Each page of memory that is set by the operating system has particular permissions and particular options. And there's a question, or there's two questions here, saying what then is virtual memory and where is the forensic value? Well, memory is going to store, it's going to store all the instructions associated with an application with an application where the application has been allocated that memory by the operating system. There would also be stored some user input of some kind, cookies, perhaps session keys, so cryptographic keys may be stored in memory. So there's a lot of forensic value to looking at the memory of a computer system. However, in order to do so, you tend to need to interact with the computer system that you want to ask questions of, that you want to interrogate. And that means that you're going to do something to that computer system, which isn't the best idea when you're performing forensics. Well, virtual memory is how your operating system is going to map your physical memory, and perhaps even use some space on the hard drive in order to provide all the applications with the areas of memory that they need to run. So there'll be some standard kernel stuff, some standard system stuff on memory, and every application doesn't need to have that mapped to each application page, and so virtual memory will ensure that system level stuff in memory is able to remain where it is and be mapped. So your virtual page for the application will map that system level memory, but then also have the application level space just above that or just next to it. On a Windows system, you're able to put the device into hibernation, we're able to completely shut off power. And what happens is that all of the memory contents, so what the computer system is currently doing, is saved to this file. The hyberfill.sys is saved to the root directory in C. And this saves system state, so what the system was currently doing when someone put it into hibernation. And then on boot, as we looked at the boot process earlier, the hyberfill.sys is loaded straight into memory, and that system state can then be restored. So obviously, if we're able to get access to this hyberfill.sys file, we're able to see what the system was doing as it was hibernated. So there is forensic value in doing that. So just to conclude this first session, Windows is the most popular operating system for PCs and laptops at the moment. There are a lot of forensic artifacts in sort of many different places, in the user directory, in the application directory, but also in the registry. Memory, page files, hibernation files may store something called volatile data, which may also help us doing forensic analysis of Windows boxes. Now, what you need to do this week is you need to ensure that you've got access to the image from the server. You need to examine that image in identifying partitions, identifying file systems. You need to identify the operating systems that are installed, and identify programs installed and possible forensic artifacts that could be available. And when we have our first session next week, I think I want to discuss what artifacts you feel are available. Okay, thank you very much.